Hello, everybody. Welcome to today's webinar. We will wait 2 more minutes just to make sure that everybody who might be running a bit late is able to join, and then we will start. Okay, I think we will start now. So first of all, a very warm welcome to everybody who was able to join today. I'm very excited that so many people showed interest in today's webinar titled Digital Urban European Twins, which is short for DUET, Connecting Europe Through Digital Innovation. First of all, I would like to introduce my two co-organizers, Gert Vervaet, the co-coordinator of the DUET project, and Thomas Adolphi, who's part of project management in Virtual City Systems. I myself, my name is Henry Farr. I also work for Virtual City Systems, and I'm part of the sales and marketing team. Yes, a few informations in the beginning. First of all, this webinar will be recorded, but there's no sensitive information in regard to the participants being shown. Also, afterwards, everybody will receive an email tomorrow with a recording of this webinar to look at it afterwards again, if you're interested. Another thing is that we invite you to ask your questions that you may have during the webinar. In the control panel, there's a questions tab where you're able to just type your questions. We will try to answer the questions during the webinar by texting. And then hopefully in the end, we will have enough time to sort of go into a short question and answer session. But every question that is asked, but we didn't have time to respond to, we will also answer these questions via mail after the webinar. Okay, without further ado, this is the agenda for today's webinar. I myself will give a short introduction to Virtual City Systems, who we are, what we do. Then I will hand it over to Gert, who will do the main part, giving a project overview, what has been happening with the DUET project over the last years, and what the ideas for the future. And exactly after that, Thomas will give some closing remarks, a short wrap-up of the webinar, and hopefully, as I just mentioned, we will have a 10-minute question and answer session to respond to any questions you might have. So Virtual City Systems, this is sort of our motto. Our vision is to use 3D city models and digital urban twins as a forward-looking platform. We believe that 3D geoinformation and therefrom derived digital urban twins are an essential foundation to understand, design, and solve the complex challenges of our urban reality. We were founded in 2005 as a daughter company of the CATFEM Group International. Our headquarters is in Berlin, where me and Thomas are currently streaming from. We have a second office in Grafing near Munich, and we are global leaders in semantic 3D city model solutions and are also experts for 3D geoinformation and digital twins of cities. Our three main areas of expertise, or where we work in, are 3D city models, digital urban planning, and urban simulations. Yes, That is all from my part. I would already hand it over to Gert now for the main part of this webinar. You should now have the controls, and I will turn off my camera to be able that there's a stable internet connection.
Okay. Hi, I'm Gert Vervaet. I assume you see my slides now, the title slides. Can somebody
Yes.
confirm, please?
Yes, perfect.
Okay, I'm Gert Vervaet. I work for Digital Flanders, which is part of the Flemish government. It's an agency that focuses on making tools and delivering services to the other Flemish departments, mainly linked to data, open data visualizations, and those kind of things. So this is the agenda for my part of the presentation. I'm going to give an introduction to DUET. I have one slide about architecture, but it's more like marketing architecture, like very high level, but it shows the different components and it shows how they interact. And I can also speak a little bit about what's important in the DUET project for next steps. Then I'm going to show a DUET landing page and cases and explain what that all is about. And then I'm going to give a long demo. So the biggest part of the presentation will actually be a demo using some of the nice tools that Virtual City Systems provides. So about DUET, about digital twins, we have right now a lot of the decisions that are being made in governments are still made from a gut feeling. But we are moving more and more towards making decisions based on data. It is often based on data from the past because there is a lot of data that is being generated and more, and everything goes faster and faster. But still, a lot of the data is just about the past. But what if we could make decisions by understanding the impact of a change before we make a change, before we change a policy, before we make a decision? And that is one of the areas where a digital twin can come in play. A digital twin is going to help us with bringing all sorts of data together, which we have also in some dashboard systems, but it also allows to do a what-if analysis and check what the impact is. What if I block this road? What is going to be the impact on traffic? What is going to be the impact on air pollution and on noise pollution, those kind of things. So digital twin, like I said, brings all the data together, and it breaks also the silos. Now in many governments, many government agencies, they all have their own responsibility and they focus on air quality, but they're not worried or not interacting with the other areas of the world and of the surroundings. So what if we could bring the information of air pollution, noise pollution, traffic, and other things, if we could bring all that together and then allow people to look at the city or at a region in a holistic view. That's also what a digital twin is about, bring everything together and break those silos. So a digital local twin is also positioned as something that people can work together around. It connects legacy systems, so like I already said, it breaks the silos and it brings data. It makes data available for different departments to look at, but it also makes data more understandable, makes data easier, so that people can react to it better. It allows us to explore policy impacts and it influences better public decisions. But by doing all that, we also want to enable cities, governments to do a what-if analysis, to present that to the general public, get feedback, and really break also that silo, the silo of decision making, also open that up so that also the general public can be involved. And be involved in giving feedback even before something is done. So we also there to be able to look into the future. Basically, that's a little bit it. By doing that, the governments can also gather more trust from the citizens because they are being more open. They're showing all the data and they're also allowing.
Gert, sorry, sorry for interrupting you. The connection is a bit bad, the audio. Maybe if you turn off your video, it's going to be better.
Okay, thanks.
Yes. Yes, no problem.
Okay, that's not what I wanted to do. I've never used this platform before, so let me find where is my video.
Exactly, perfect.
Okay, thanks. You close it. Okay. Yeah, somebody else close it for me, so you should thank them instead of thank me. So I hope that it will be better now. I apologize for the breakups. Let's see whether it becomes better. Where was I? So by being more open as a government, by involving people from the start until the end of a decision-making progress, you also gather more trust, and you will also get better decision-making, basically. The next slide. I already mentioned this a little bit. So we combine a lot of different data sets, and we show that as a digital version of the city. The idea of a digital twin comes from manufacturing in the past, where people in the past there were no digital twins, and then they started making a digital twin, for instance, of the engine of an airplane, because it's obviously very expensive to build one, and they built a 3D model of the engine of the airplane. Then there were experiments happening there, and then the experiments were when the experiments were successful, only then a prototype was built, and then the real thing was built. So the idea is that we do the same with the city. We bring everything together. We build a virtual version of the city by combining all that data, putting some nice visualizations on top of it so that it becomes much more easy to understand, and then people can use it in the decision-making process. What we also want to do is in the backend of a digital twin, there's a lot of heavy machinery that are doing all the calculations. So in some of the legacy systems that we have right now, you really need very heavy computers also in the hands of the decision makers to be able to show data, play with data, manipulate data. But that now all happens, mainly happens in the backend. And it also facilitates the broader pickup of it. And so making data easy to understand, yeah, we already touched on that, and provide an integrated view of the city, bringing everything together and facilitating decision making. What's very important also when we talk about data is that we also need to think about different aspects of the data. Data quality is obviously very important. So that is something that's almost, it is a prerequisite of having good digital twins, or having a good data-driven decision making. One of the prerequisites is obviously having a good data quality. And data quality has many different aspects. The data needs to be consistent, so it needs to be according to the specifications. If a field is supposed to be a number, then yeah, the data should contain it as a number. If it is supposed to be 1, 2, or 3, it should not be 7 or 8, because then it is not consistent and tools might crash. But it also needs to be accurate. So when maybe, like for instance, spatial accurate, if a road is or if a building is in the middle of a street, then it's also going to obviously have impact on decisions. The coverage also needs to be good. So you need to have data of the complete area that you want to make a decision about, not very spotty, just here and there, maybe an air quality sensor, but then big gaps in it. That also will help, will not help have good decisions on data. The freshness of the data is also very important. Is the data up to date? Are we not just looking at old data? So you obviously want to have a fresh data, and it needs to be complete also. And then but when you start combining data, then the interoperability of data is also important. So you need to find mechanisms to link data together. In DUET, we have chosen the OpenStreetMap data as a kind of the hook between different things. So the traffic model works on OpenStreetMap data. The 3D model is positioned according to the OpenStreetMap data. So we use a spatial hook as a interoperability. And then when people start using the data, then there is also the need for a data literacy. People need to understand the data. You can give training on how to use data, but obviously having nice and proper visualizations and good tools will also help. And it's always better to make sure that the tool is very clear than that that you need to have a lot of pop-ups with information or training or things like that. So I already touched on this. So the experimentation, the co-creation, so you need to make sure that there's data literacy, that people understand it. Then you can really change things for the better. You can deliver a social goods. You unlock innovation, because people that are always sitting in their silo and think about a certain problem, they will obviously most of the times come with similar solutions as in the past. But by bringing people from different domains, but also people that may not have been involved in policy making at all, bringing those people together, that will also unlock innovation, because there's always more ideas when you bring people together than when you add all the ideas of the individual people up. By having a digital twin and making sure that that your visualizations are well chosen, you can also measure and predict the performance. That's the what-if analysis, and yeah, where we talked about bringing together stakeholder capabilities. Okay, this is the architecture slide, the next one. So, but it shows the different components, and it shows what we built. So what you're going to see is real stuff. I always like to give real demos, and it's very exciting, and it sometimes goes wrong, but that's then a part of the deal. I don't like to show movies or slides. So in the middle here we have a T-cell architecture. I think it was actually Thomas from Virtual City System that came up with the T-cell connotation, or with the analogy. This happened just before the first corona outbreak. We were together in Athens and we flew back, and people were beginning to wear masks. So we didn't know that the T-cell would become something that more and more people will know and understand. But the idea of the T-cell architecture is that in the beginning, in the middle, we have a core with the data catalog. What are the different data sets that are available? What do they look like? What are their aspects? Who can access them? Those kind of things. A model catalog. What are the different models that are available? How do they connect to each other? What is the output of the one and will be the input of the other model? A message broker, which is a very important component, and you will see it grab information from the screen in the demo, virtually grab information from the screen, and then push things back to the client. So that's also going to be clear. And a knowledge graph is something that we just touched in DUET. We didn't work on it as much because we have, like I said, we use a spatial link between the different components, and we have the idea that for next versions of DUET, for follow-up projects, we should have some kind of knowledge graph describing the different aspects of policy making, of traffic, of air pollution, noise pollution, those kind of things, and then show how they map. Like say a road in air pollution is maybe something else than in an air pollution model. The input for a road in an air pollution model could be slightly different than for a traffic model, and we would then have like mappings between those things. But we didn't we didn't build that out as far as we could, but that kind of should happen in a follow-up question and follow-up projects. And in the middle, there's an interaction service, and the interaction service, you will see that also in the demo. I can edit part of the map, or make a what-if analysis on part of the map, and then send it to the back. And then that is the interaction service that then says, okay, now there is a change package, and that's then sent through the message broker to the different components. And then on the outskirts, integral parts of a digital twin, but more loosely coupled, you have a lot of data, amongst others IoT data, but it can also be other kinds of data. Reference data, like the road network is reference data, maybe some weather information can be weather data, those can be reference data, those kind of things. We also have models. You will see a lot of those, or at least the input and the output of those. So we have different models that look at at the T cell, that look at the message broker and check if there is a message that is of relevance for them. They will grab that message, they will work on it, and then they will put their output back on the bus, on the message broker, and then another model could pick it up. So for instance, I'm going to demo later that we block a road, that we do that in the interaction service through, well, maybe, yeah, through the visualization. We do that in the interaction service, then we put it on a message broker, and a traffic model will see that. It will calculate an updated state of the traffic model, will push it back. Then an air pollution model will say, well, an update to traffic, that is obviously going to have an update or potentially going to have an update on my air quality state. So it will calculate also, and so will the noise pollution model, and then they will push the information back, and the visualization client will grab that. So that's a very, very high level. Like I said, it's architecture, but very high level, how the different components work and how they interact. It also gives already a little bit of a spoiler for the demo that we will have soon. Okay, last set of slides, or last slide, I think, before we dive into the demo. I'm checking for time, I think I'm okay. So we built next to for me, I'm a technical person. I like code, and I like to work with technical stuff. So but next to that, which is important and which is much fun to build a backend and build services and build models that interact with that. Next to that, we quickly also realized that we need something else also to help the user, to ease them in and to explain to them what is DUET about. But that's just the website. But we also figured out that we needed something like a case, and a case in DUET is a case is you could see a case a little bit as a dedicated view in a digital twin, incorporating all the relevant data sets, all the relevant models for a certain problem analysis, dissemination activity, broadcasting activity, those kind of things. So it's almost as if somebody prepared a dedicated digital twin, a completely new instance of a digital twin, especially for a certain problem or a certain aspect that we need to that we want to look into. So I'm going to give a couple of demos for that and a couple of examples for that, so that it becomes more clear. Next to that, we have the 3D map viewer, which is based on the technology of virtual city systems. We have then the DUET website, which is just a general project info. Okay, live demo. Let's go. You still see now you see the digital platform. That's good. Okay, so this is the landing page. You can go to citytwin.eu if you want. I don't know what's going to happen if like 1,000 people go to it at the same time. We still need to do some stress testing. So please wait until at the end of the presentation. We lifted the landing page a level higher. We used to have like one landing page only for DUET, but we have a couple of sister projects, Urbanos, which is focusing on digital twins for people of higher age, for elderly people, and it helps them to it helps the projects to think about how can we make life easier for the ever increasing population of elderly people. So we have we have a page for DUET for the 3 different pilots, and we have one for Compare, which is sort of a follow-up project of Compare, where we're going to dive more deeply into the combination of air sensors, air pollution sensors, and traffic sensors, and then work with local teams, with crowd science people to on a local level have an impact on air quality. Okay, let's maybe go to a case of that one of those as sister projects. So Urbanos is that project that I was talking about, and this is what a case looks like. So we start with a challenge. What is the challenge of this individual case? And it's about extreme heat in the summertime. So that's a challenge. Then what's the approach of I'm not going to read all this. You can read it yourself. But what's the approach that we're going to take? So we're going to look at the terrain data, the spread of trees and buildings, and then see where is there a lot of shadow on the different times of the year and different times of the day, so that we know where is a good idea to put maybe some benches or have impact on that. So scroll down. There's also how to use data, use models. Those are the things that you can also see when you look at the case. And then there is a button here, see this case live. So if we click on it, now this case with ID 330 is now loading, and it's grabbing all the information that is relevant for this particular case. So what do we need? Because we want to check shadows. We need the 3D buildings. And in Ghent, we have a level of detail too. 3D building that and this bit here is actually under the ground. And the trees are there. And there's also on the backdrop, obviously, there's also the roads, and there's also a 3D model, a digital terrain model here. So as you can see, there is like some slope happening here. So if we now enable this functionality of checking where the shadows are, we can move through time, and you see where the shadows are now, or where there will be later. But also using the technology of virtual city systems. I get paid if I say virtual city systems enough, then I get paid more. So that's why I see it a lot. You can also go through time and see, like in the winter, there's obviously a lot more shadow, and it takes longer for the sun to rise. And in the summer, it is better. This obviously is very clear, but here you can then really go in much detail and say, well, does it make sense to put a bench here, or should I put it maybe closer here, or maybe under those trees, and what's going to happen at those kind of things. So that's an example, a very simple case. It's not there's no models involved, as you could see also when I was showing the information on the case. But it is bringing together. So one of the aspects, remember, of a digital twin, bringing together all sorts of data and then help you reason about it. So that's one of the things that we did. I also wanted to show, just FYI, obviously there is capabilities to add much more data. So this is like a reference map of Flanders. Maybe hides the 3D building. So now, instead of just having an OpenStreetMap, we also have this reference map. Where is it? Here, the reference map. So on top of OpenStreetMap, we also have the colored OpenStreetMap. So I remember bringing together data. I'm also going to maybe add this is maybe also interesting, just completely different data. These are the contours of noise around the railroads. So it's again, and then you want to maybe do an analysis of what would happen with if we put a wall here to prevent that. Then we could. I'm not going to do that now, but we could add that and then see what the impact would be on noise pollution. Yeah, that's the important things that I wanted to show in this case. Now I'm going to do a what-if analysis, which is the most exciting part of the demo, because yeah, there's a lot of moving parts there, but I'm very confident that I will get it to work. So let's first fly to Ghent. Now I'm in Ghent. I want to load the yeah, I'm in the development environment also to make it even more exciting. So I load the Ghent road network data. So what you see here is a KU Leuven, which is a university in Flanders in Belgium. They built a traffic model based on the information of the Ghent traffic model. So they used the origin destination matrices. The loads on the network are then calculated on the OpenStreetMap data, and that's what you see here. now I want to do an analysis. So I go here to my favorite bridge, because I always use this because it gives very nice results and very meaningful results if you show this, and easy to explain. So I selected those two roads and then I clicked on block them. So I blocked the roads completely, and now the information is sent to our traffic model. No, it's actually not sent to the traffic model, it's sent to our backend, and the traffic model then sees it passing by and says, ah, interesting for me, I'm going to do something with this. And then it starts calculating, and it then puts back the information on our bus. And then the client sees, information that is interesting for me. I see there is an update to the traffic model. I have an old traffic model, I have a new traffic model. I'm going to calculate the delta, and then I'm going to show it on the screen. So that's what happened here. So that's all done in an automated way. I saw that Leah from that used to be part of the project was here, and then she was saying this is all very complicated. So I think she will agree that it's become a lot less complicated. So now I close this this bridge here. So obviously there is a lot less traffic here and no traffic on the bridge, but people still need to go somewhere, so they then go around this bridge. What's interesting to see is that they're even very far away. There is impact calculated by this traffic model. Obviously, a traffic model is taking information. It's a theoretical model. It's redistributing information. It's redistributing traffic over the other roads based on the assumed patterns of traffic. There's definitely a level of doubt there, or a level of it's not a black and white thing. It could there could be some deltas there. In the meantime, I'm talking too much, I think, because in the meantime the air pollution model came back. So the air pollution saw there is an update to traffic. That's definitely going to have an update on the data that I have on my state, and I'm going to calculate it and then send back. The air models they are built by TNO. They sent a result, a reference, and a delta. In the previous model for the traffic, it was a front end that was doing the calculation of the delta, but now the back end is doing the calculation. So we also wanted to explore the different paradigms of doing these kind of things. So now you see everywhere where hopefully everywhere where the traffic is reduced, we have reduced air pollution, and when there is more traffic, there is more air pollution. We also wanted to work on accessibility. You see, typically when you see a heat map or a map that shows increase and decrease, things are shown in red, yellow, orange, and green. But the difference between red and yellow, red and green is for I think 10% of the male population is impossible to see or very hard to see. So I've chosen a color palette that facilitates that. So the difference between this green and this pink is visible for somebody that is suffering for daltonism. So that's something that we also focused on for this project, for this proof of concept. But we hope also by doing this and by talking about it, which I'm doing now, that more people become aware that this is a real problem, or it's a real challenge that people have. So we might as well be more inclusive and also take away that hurdle. So I'm talking a lot now also because I want to see the noise model come in. It should arrive soon, I think. I can check here. There's this is where the queue is. So it started 3 minutes ago. There's also another model that is running in parallel, but that is slower than the others because it calculates different aspects of air pollution model. But we mainly built this because remember when I was showing the architecture, there's models that are at the bottom. One of the most important things of DUET is that we don't just build a solution that works with a couple of models, and if you then need to have more models, that there's a lot of coding that needs to happen. We built our core such that it can relatively easily connect to, or that other models can relatively easily connect to it. So that's what we wanted to prove with this V2 model. That's a Flemish institute, technology institute. And we made a deal with them and we asked them to connect their model also to DUET. And by using some sample code, they very quickly, I think in 1.5 weeks or something like that, not working full time, they were able to connect their model to our system, which is for us a very good, very nice result. In the meantime, the noise model came back also. I'm an IT guy, so I don't know much about the models. So I can't explain very well why the air calculation model is staying close to the roads that are updated and the noise is going a lot further. I can't really explain that, but it's nice pictures, so I show them. But so experts obviously will be able to explain that these are also our existing models that we connected in the light of DUET. We didn't build these models; we connected them to the DUET solution. Okay, so even though we worked hard to make these things easier, it's still a lot of work, and you need to know exactly what you want to do before you can do a what-if analysis. So to make it even easier for people, also for people on the street to work with these kind of technologies. That's one of the reasons why we have these cases. So I'm now going to open a case, an existing case where a traffic, the same what-if analysis basically as what I showed before has been done. The results have been saved and they've been made available through a case so that people can look at it without having to do any analysis themselves. So I click now. Again, there's a challenge. How best to visualize the simulation of the impact of road closure, blah, blah, blah. What's the approach? We have two colors, gradient, delta layer. I know that was one of the problems that we had in the beginning was that a colored map on top of a colored map doesn't work very well. So now we have a grayscale solution for that. Here is an explanation on how to create those delta layers that used to be necessary. But if you now go to the case, then all the information is loaded, the traffic model is loaded, the resulting data is loaded, the delta layer is calculated, and now it was supposed to show it, but obviously it's not. So let me try it again, and if it doesn't, then I'm going to manually click it on. This is something that is okay. So there's still a bug here. It mainly doesn't work on my machine. It mainly works on other people's machine very well. But on my machine, there's still an issue. So I was working with Thomas to try to resolve this. But yeah, we thought we had it, but obviously not. It wasn't running for the first time. But now you see, so this is a road that is being blocked. People can zoom out and see it. The person that people that are paying well attention, they will see that the colors are wrong, and they are wrong. This is the production version. There is a bug there. We will fix it. It is already fixed in development. We need to put it out there, but we didn't want to do that just before this demo. So after the demo, we're going to do that. Yeah, the colors are reversed. That this should be green. Everything that is green should actually be green, and everything that is pink should actually be pink. But yeah, I kept it in here anyway, just because I wanted to show how a case is working and how it can help people. But now people can also give feedback on this by just giving their email using my personal email. Oosh, that was not what I wanted to see. Let's hope that it. Yeah, okay. There's something not there in the backend, but fortunately it doesn't hamper me to give the rest of the demo. So people can now give feedback on. I know it is stopping me to. Okay, the second time it worked. So I can say okay. Very weird. People so if you share this with citizens or with colleagues, it doesn't have to go to the general public, but people can give feedback on that, and then other people can read that. They can vote on it. I can even vote on my own. So there's still some fine tuning that we could do. It's just a proof of concept, so we just show what would be possible. But this is showing what what people, how this digital twin can work in a co-creation project. So people can give feedback there. We also allow, so that's on the very detailed insight, a very local part of the result of a what-if analysis. People can also give feedback on the complete case. Just type something in and leave their name and their email, and also on those people can vote also, and then the hottest comments will appear at the top. But this is our quote-unquote production version, so I'm not going to write any crazy stuff on there. Okay, I'm running a little bit out of time, I think, but I can still. Okay, so I ran. No, okay, this I showed already. I ran the veto model ahead of time, just to show that it indeed does work, and it shows NO2 model. It shows a PM10, which is a fine pollutant of a 10 micrometer, I think, and a 2.5 micrometer. So this is what the impact would be on the NO2, and this is what the impact would be on the PM10 and the PM2.5. This is the result of that external model that is running at their premises. So the only thing we do, or they do, is listen to our bus and then put something back when they're done. Okay, let's fly to Belgium. So we have three. I already said that. I think we have three. I can't type and talk. Try that, but I can't. We have three pilots. We have Flanders, Belgium, and Athens. So let's show something of the Belgian pilots. It's a smaller city than Ghent. So I'm running something there on the traffic model goes faster. So I'm going to use it to give a demo on some other functionality that we have. When we gave the first when we gave the first demo of doing a what-if analysis, we got feedback. Yeah, okay, but blocking a road. What if you don't want to block a road, but maybe reduce a lane of a road, and then calculate what the impact is? And yeah, we hadn't planned to build a solution for that, but we thought it was such an interesting case that we did also implement that. So I'm not going to block the road completely, but I'm going to reduce the capacity to 50%, and then do a start an analysis. So now it's sending again to the same bus, but another model sees the information. It's very quick, like I said, and it runs, and then it shows what the impact would be. This model is showing, yeah, the delta is showing where there's a decrease of traffic and an increase of traffic. There's not that much of impact if you reduce it to 50%. So you could say, well, let's maybe try to reduce it. Oh, I first need to select my traffic model again, otherwise I can't click on a road. So click here and then maybe reduce it with 80%. So it's not to 80%, but with 80%. Calculate it again, and then there should be a bigger impact on the model, on the traffic. Get rid of the traffic model. It's actually the same. Okay, let's block it then completely, and then we will see what the difference is between what we used to have and what we now have in the system. Just a sec. So block it completely, putting the traffic model to work again. And now we see a much bigger impact on the traffic. There's more roads involved, and it also goes further. If you block a bridge, one of the main bridges coming into the city, then obviously there is a big impact. I also quickly want to show we also have models in Athens. So we have I blocked here in the middle. I blocked a part of the traffic in Athens, and then I let the models run. So I got an update to traffic, an update to air, and an update to noise. And you can see it. The data is a little bit stale. I ran it before. I didn't want to waste your time waiting for it because it's quite a big model and it takes a while to run. And you see here the Hello Kitty version of pollution and noise pollution. So this looks a little bit like a pink kitty. That's what I wanted to show. That's it for the demo. We're now going to go back to the presentation, and then Thomas is going to talk, but I made slides because I was prepared in case something would not work. I have, yeah, okay. Then I had some backup slides so I could talk to what you were supposed to see, but everything worked, so I'm happy. All yours, Thomas.
Yes, thank you, Gert, for your nice presentation. It was good to see that everything worked well.
Of course.
Yes, because you did it. What we learned, or at least the lessons learned, so from it's a bit from VCS side, but also I would say from a general point of view, is the first thing is that we do not have only geometries in our digital twins, right? And not only the pure visualization. So what we all the time, and it's, you probably know that graphic from a bit of from CityGML, but it's also valid for the digital urban twins, that we have a lot of things below the top of the iceberg. So that means everything underwater. We need, in order to connect data to each other, we need that in order to know what is linked to what everything else. So we need to link models to each other. We need to communicate from the visualization to the to the models, to the simulation. We also need to integrate these model results into that one. And for most of that, we need semantics. We need the meaning of that one, and we need proper relationships between all those features we are working with. Get the next slide, please. So we as VCS also learned that the digital urban twins are more than pure 3D visualizations. So we need way more interactions with our maps, with our visualizations. And we need to tackle also the fact that digital urban twins, or at least the cities itself, are far away from being static. So just to make that clear, so VCS is coming from a historical point of view. We are coming from hosting static maps. So that means usually our customers come up with some data and they want to see them in the in a map, in a browser as a 3D visualization, and that's it. And now we are seeing that working with all those city models or with all those visualizations means that we have to be dynamic as well. So we have to change our visualization to a more dynamic point, away from that static hosting of data sets. And we also learned from DUET that the digital urban twins are an information platform for citizens and administration. So that means they are information platform for experts and non-experts. And as also Gert showed, that for sure we do have now a UI which is more for experts, so in creating all that what if scenarios and so starting a case and all that stuff. But we also provided that for non-experts, so by saving all the results and experiments, putting all together in cases and scenarios, so that each non-expert can simply call a map, or at least open that case and see then, okay, what's going on with that case, and you can inform people or non-experts by just providing those kinds of organized or saved maps. And as you have seen as in Gert's demo as well, it's a playground, right? Each digital urban twin could be a playground for various domains, because you can easily do a new analysis and checking out then the result. As you have seen that for Pilsen, as Gert was just changing the from 50% to 80% and then to a complete blockage of a road, and then you can see, okay, what is the effect of that one? That means also that digital urban twins needs to be interactive. So as you have seen, that you can now also play around with all those data sets in the viewer directly, and thus it's dynamic. And what we also understand is that digital urban twins are really complex. So that means we have just shown here some, I would not say easy cases, that are for sure complex cases, but are not complex as a city itself. So we can understand this city as a system of systems, and we just have shown here a small portion of that, what is possible and how the system interacts, or at least the system as seen as a city, right? So it's really complex, and we just have shown here a portion of that one. The next slide, please, Gert. So we, as VCS side, we learned that we definitely have to do more improvements on our visualization side. So that means going more into a dynamic view, into a dynamic environment. And what we also have learned is that the visualization is a part of the dynamic twin architecture and not the dead end. So dead end before was on that static hosting. So you provided the data and you can see your data and you can go around, you can move in your 3D world and you can see that. But right now in the digital urban twin, the visualization is part of the architecture, means you're going to interact with the visualization, and then you're enforcing models to run, you're enforcing simulations to do something, and you're going to provide or to get the results out of that one. And that means in the end that dynamic loading of data needs to be supported, as Gert has shown with that message broker, getting the message, getting the data, and then automatically integrate them in the viewer if you want to have that. So that's valid for simulation results, but also for sensor information. So means that you're just subscribing to some kind of sensor data, and you're receiving the updates of a sensor once the data is there, and you do not have to care about as a user to get the data new and to load the data again. The next one thing is also the styling of data. So you would like to deal with some original data set, for example, like having just gray buildings, and you would like to visualize then the angle of roofs or the amount of surface or whatever, just by applying some styles on that one, some highlighting the portions of the buildings you are interested in. And what you also have seen here is the loading and saving of several displayed contexts. Means that what Gert has shown with the case, you have a superior case or a root case, and below that you have several scenarios, which means you're saving your context, or at least your experiment in below that case, and you later on can simply access it, and you can visualize and you can provide it to non-experts. Yeah, so analysis triggers and getting and visualize the results of analysis, that's for sure a thing which needs to be improved on the VCS side more, and also on the DUET side, I would say so. But that are the next steps we are going to do to improve that a bit better, and using the interaction service and a better support for sensor integration and visualization. That's what we learned and what we also see for the future, to provide better APIs and better access to at least sensors and also simulation results. Okay, so that's it from my side. That was the wrapping up. And I think we have 5 or a bit more minutes to answer some questions if there are some available.
Yes, exactly. Thank you, Gert, and thank you, Thomas, first of all. I'm looking at the questions, and so far we've been able to answer every question by now. There's one question. How about the concept of connected digital twins? Is this within the scope of DUET? And if so, what are the activities? Gert, you already replied, but maybe you want to do it by word, something?
I would first like to understand the question a little bit better. I tried to answer it, but maybe I didn't answer the question. And so if Vital, if you feel like explaining a little bit more your question, and if not, I can just talk to the question that I assume it is.
Okay, maybe we will wait until the person that asked the question maybe elaborates a little bit more. I thought a really interesting question that you already answered, but maybe you can elaborate on this, is how do you validate the results of these models and manage the inherent uncertainties, especially when these models will provide the legal evidence on which policy decisions will be based? You gave the example of the traffic model, that it's sort of a state of a moment, and there's always a certain level of uncertainty. And since these will be used for policy decisions, I think it's a very interesting question.
Yeah. Yeah, I tried to answer it also. It is indeed a very interesting question and a difficult problem to solve. We do need to take into account that DUET is a proof of concept, and it shows what could be done using a digital twin and how different models could work together. We think it's the first of its kind to really show how that could be done. But what we did not do is validate those models. So we worked using existing traffic model, existing air and noise pollution models, depending on where we are in the world. So there's another noise model for Pilsen because there was one available, and for the others we use the TNO noise model. I also put in my answer that it's not only important to validate the model, but when a decision is made using DUET or using another digital or using another data system, it's going to be very important to store the vintage of everything that you used, all the different artifacts. So what version of the, not just what data did you use, but what version of the data did you use? Did you use a query on the data or did you use all the data? Because the first decision in a policy making process is what data am I going to use? You already make a decision when you pick the data set that you want to use. So not just the model, but also the data, what parameters were put in, all that needs to be stored so that you can reproduce the what if analysis. If in the end you get a question, why did you make this decision? And it's indeed not going to be enough to just say I use DUET. It's going to have to be much more detailed than that. But we did not do that in this project. And Vital,
All right.
Vital put he's on mute, so he can't elaborate. Yeah. The models are we don't push anything to the models. The models come and grab things from us, and the models are not open source. They are from the different teams that built it. So you can't access them to connect to your own digital twin, I'm afraid.
Okay. Looking at the time, we're 1 minute away from the end of the time slot, and so far we've been able to answer all the questions via chat. As I said earlier, we're going to send everybody who participated a recording of this webinar tomorrow, and I will also make sure to send the typed out answers to the questions that were asked via mail to those that asked the questions. Yes, feel free to contact us. You can see our contact information right here. I will delegate any questions to specific people. And if you're interested, we have a range of webinars from the past on different topics. You can check out under gotostage.com/channel/virtual city systems. And yes, first of all, I would thank everybody who took the time to participate. I'm very excited that so many from a range, broad scope of groups that came today to the webinar. And a special thank you to Gert and Thomas for a very entertaining and insightful presentation of the DUET project. I hope everybody learned something today. And with that, from my side, I'm going to say goodbye. I wish everybody a nice day and hopefully see you again with our next webinar.
Thank you. Bye-bye.